This year, SpaceX will likely conduct their Crew 7 mission, which will be the 8th crew rotation flight to the International Space Station with their Crew Dragon spacecraft. As usual, 2 NASA astronauts will be aboard, along with 1 cosmonaut from Roscosmos and 1 astronaut from the UAE. The mission is expected to launch in May or June. Next up, SpaceX will likely conduct their second mission of their Polaris program. Polaris Dawn will be an uncrewed test flight meant to test the spacecraft systems in orbit, but also validate the capabilities of SpaceX's new Starlink-enabled high-throughput communications system that will enable SpaceX to support more crew on their Dragon vehicle. The primary payload will be a large communications and scientific research payload called the Slingshot, which will remain in orbit for up to 5 years after separating from the capsule. Polaris Dawn will likely launch in March. Later this year, Boeing will conduct their first orbital test flight of their Starliner spacecraft, which will be known as the Uncrewed Orbital Test or UOT. We are hopeful that this test flight goes well, because Boeing has been contracted by NASA to develop their next-generation space station called the Orbital Reef in partnership with Blue Origin. Boeing has been struggling to get this project off the ground for some time now, and it would be nice to see them finally make some progress here. Finally, later this year, NASA will conduct a test flight of their Orion spacecraft with the Artemis test flight set to launch no earlier than late 2024 at the earliest. Originally, the plan was to conduct an uncrewed test flight of Orion first, but because all of the hardware for Artemis 2 is already complete, they decided to skip the uncrewed test flight and go straight to the crewed version. NASA is planning on sending 4 people on this mission. 2 of these seats will be occupied by NASA astronauts, while the other 2 seats will be occupied by 2 Russian cosmonauts who will be flying on the Orion spacecraft for the first time ever. If everything goes well on Artemis 2, then Artemis 3 will be scheduled to fly in 2025 with the goal of landing astronauts on the moon for the first time in 50 years. Now those are the big things that we're looking forward to in human spaceflight, but there are plenty of other cool things that are happening right now that you might not know about. For example, a company called SpinLaunch recently completed their first ever full-scale test of their suborbital spaceplane. Now this is a spacecraft that's going to be capable of taking people into orbit anytime soon. It is more of a concept demonstrator to prove that SpinLaunch's unique method of launching vehicles using a giant slingshot actually works. But if it does work, then it could be potentially game-changing. Because unlike most other launch systems out there, SpinLaunch doesn't use any sort of rocket propulsion system. Instead, they literally just use a giant slingshot. The current world record for SpinLaunch's system is around 600 miles per hour, which is over 3 times the speed of sound. And when you're moving that fast, you generate a ton of kinetic energy. And kinetic energy is what creates the lift to push a vehicle into space without the need for rockets. There's a whole physics equation behind it, which I won't bore you with here. But the important thing to understand is that by removing friction and drag, a vehicle that achieves 600 miles per hour will reach space. That means that a vehicle like this can be built without the need for heat shielding, which makes it cheaper and easier to build. Not to mention that it eliminates the need for expensive and powerful rocket engines. In theory, SpinLaunch's system can launch vehicles into space for as little as $1 million per launch. And yes, that's million with a lowercase m. That's a fraction of the cost of a Falcon 9 launch. So obviously, this technology is incredibly promising, but it still needs to be proven. The first step is getting their suborbital test flights working consistently, then scaling up to larger and larger vehicles that can carry bigger payloads if it all works out. SpinLaunch says that they want to begin launching satellites into low Earth orbit by 2028 and eventually move into launching crew and cargo to the moon. The way that they see it, SpinLaunch can be used as a fast, cheap, and efficient launch solution for missions that are close to Earth, while rockets like Falcon Heavy can be used for missions that are farther away. SpaceX, Blue Origin, and now SpinLaunch are all vying for a piece of the space transportation market. But there's another company that's looking to break into this market as well. Astro, which was founded by former SpaceX employees, is developing a reusable orbital-class launch system. Unlike SpinLaunch, Astro is pursuing a more traditional approach to launch. Their vehicle will use chemical rockets to achieve orbit, but they will use a very clever method to land the booster stage back on the ground. Most rockets land their booster stages back on the ground, because the amount of kinetic energy required to bring the booster down safely is so great that the engine needs to be able to produce a tremendous amount of thrust to slow the booster down quickly enough to avoid damaging it. Most rockets simply cannot produce that amount of thrust because the vehicle is designed to maximize efficiency, not safety margins. Astro's solution to this problem is to make their booster use air braking to slow itself down during re-entry. Air braking uses the atmosphere to slow a vehicle down instead of using pure rocket power. By having the vehicle pass through the atmosphere at a shallow angle, the atmosphere provides the majority of the braking force, while the rocket engine only needs to provide the remaining thrust to ensure a soft touchdown. This requires the vehicle to have a very high drag coefficient, hence why most rockets aren't capable of this. But by designing their booster to be as aerodynamically and efficient as possible, Astro is able to reduce the amount of thrust that the engine has to produce by 80%. That means that their engine can operate well within its safety margin, giving it the ability to perform controlled landings, just like SpaceX's Falcon 9. The biggest difference between Astro and SpaceX, though, is that Astro wants to land their booster on solid ground. That means that they have to deal with the complexities of operating in airspace and landing on a precise target. SpaceX, on the other hand, lands their boosters at sea, which removes a lot of those complications. But Astro says that the benefits of landing on land outweigh the complications. For one, landing on land allows them to reuse their booster a lot more frequently. SpaceX has to wait until their drone ships sail back to port, which takes days. And then they have to wait for another recovery ship to come take their place. But if Astro can land their boosters on solid ground within minutes, then they can reuse their boosters multiple times per day. Also, because they're landing on solid ground, Astro can recover their boosters using standard road vehicles like trucks and railcars. They don't have to worry about the complexities of operating at sea or recovering their boosters using custom marine vessels. One of the main reasons that Astro has been able to attract so many former SpaceX engineers is because they have access to a lot of capital. Astro has raised over $270 million in funding from investors like Addition, Andreessen Horowitz, Khosla Ventures, Tiger Global, and Y Combinator, just to name a few. All of this money has allowed Astro to rapidly develop their launch vehicle. In fact, they've already built and flight tested a suborbital prototype, and they well into the construction of their first orbital-class launch vehicle, which they call the Centaur. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. And if you'd like more, we've got 2 more on the screen for you right now.